Okay, a brief reminder about scientific notation, something that you need to use for this next section. So here we go. Scientific notation is a way for us to express really large or really small numbers in a way that is easier to read and easier to put into calculators. So for instance, the speed of light, 300 million meters per second. Nobody likes typing that many zeros in, so we put it in a scientific notation, which I'm going to start my decimal point. I'm going to move it 8 places, so it's 3.0 times 10 to the 8 meters per second. These mean the same thing, and I need you to recognize those mean the same thing. In your calculator, and often when you're typing, if you need to type on a keyboard, it is convenient to be able to use the letter E, capital E, so lowercase e means something different. I would write this as 3.0 capital E times 8. So all three of these things mean the same thing. So 300,000, 300 million, you might be able to get that into your calculator, but we're going to be dealing with even larger and smaller numbers. So Avogadro's number, 6.02 times 10 to the 23. This is a mole. This is a common value that we'll use in chemistry in a little bit. And there is no way you're going to want to write out 23 zeros behind, or I guess, whatever, however many zeros you need behind that. That is just way too painful. So we'll be able to use this. So I could write this as 6.02 E23 in my calculator, and that will be the same thing. And this is a really convenient way to express a really large number. We're going to be dealing with light. Light has the speed of light, but also we're going to be dealing with frequencies that are really small. So I might have something which is have 5.40 times 10 to the minus 7 meters. So if I have blue light, the wavelength of blue light would be about this value. And if I was to convert this into a standard number, like, what am I going to do? So it's -7, so it's going to be a small number. So I want to move my decimal place to make it smaller. I'm going to move my decimal place 1, 2, 3, 4, 5, 6, 7 times. So I'm going to end up with, put a 0 in the front. 1, 2, 3, 4, 5, 6 zeros, and then my 5, 4, 0. Again, so what I want to be careful about, so a negative exponent means I have a really small number, right? It's going to be a small decimal. A positive exponent means I'm going to have a really big number. A couple of brief examples. So if I have 523, I can write this in scientific notation. Right? I'm starting my decimal place. I'm going to move it twice, so I'll have 5.23. I've moved it twice, so it's times 10 to the 2, right? So this is the same as multiplying this number by 10 2 times. So convince yourself that makes sense. If I have a small number, 0.00315, when I convert this to scientific notation, notice what I'm going to do. I'm going to move my decimal 1, 2, 3. Notice I move my decimal the opposite way. So it's a small number. So I'm going to have 3.15 times 10 to the minus 3. So this is like dividing by 10 3 times. And we're going to be going back and forth between these, so I need to get a little bit of practice. There's a link to a place that'll get you a little bit of practice, but these are the key things. So I need to be able to get between these scientific notation and standard notation and know what that means and represent that in a calculator. So 3.15 E minus 3. If you type that into the calculator will know what you're talking about and help you out. Hope this is helpful. Talk to you soon. Bye.